Bob is pulling a 30-kilogram filing cabinet with a force of 200 newtons, but the filing cabinet refuses to move. The coefficient of static friction between the filing cabinet and the floor is 0.80. What is the magnitude of the force of friction on the filing cabinet? Alright, let's start by drawing a free body diagram here. So here we've got a dot that represents the filing cabinet. What forces are acting on it? So we can always start with the force of gravity, which always points straight down. And Bob is pulling on the filing cabinet with a force of 20 newtons. Alright, so it doesn't tell us which direction he's pulling on it, so we're just going to assume that he's pulling on it in a horizontal direction. He's trying to get it to move. And we'll say it's 200 newtons. So I'm going to just write this out as force applied, which would equal 200 newtons. The filing cabinet is on a surface, so it would have a normal force acting on it. And because it's refusing to move, okay, it's not actually moving, we must have a force of friction that's opposing the force applied. Now the force of friction, this time since it's not actually moving, this would be the force of static friction. And because it's not moving, then this force of static friction must equal the force applied. Okay, so those two would cancel each other out, so there would be no net force acting in the x direction. It started off at rest, so it would continue at rest. Alright, the force of static friction can never exceed the force applied, because if it did, then that would imply that the object is moving in the direction of friction, and it would actually be accelerating in that direction. So imagine you're trying to push something forward, and actually it starts accelerating in the negative direction. It's moving towards you. That never happens, right? So the biggest value of the force of static friction could be is that which makes the net force equal to 0. Meaning that the object is still not moving. Okay, so the coefficient of static friction is given as 0.8. What is the magnitude of the friction force of the filing cabinet? So we're trying to solve this force of friction here. So let's solve for everything that we know. So we have the force of gravity, which is always mg, and m is the mass of the filing cabinet, which is 30 kilograms. G is 9.81. So I can multiply these. 30 times 9.81 on my calculator is 294.3, and that's in newtons. And then there are no other forces in the y direction, so we know that the net force in the y direction has to equal 0 because the object is not accelerating in the y direction, right? The filing cabinet is not flying up into the sky or falling through the ground. It's not even moving in the y direction, so that means it can't be accelerating in the y direction, which implies that the net force in the y direction is 0. So what are our two forces in the y direction? We have a normal force, which points up, so it's positive, and we have a force of gravity, which is negative since it's pointing down. So that means that the normal force in this case has to equal the force of gravity. So we know now that the normal force is equal to 294.3 newtons. Okay, so now we also know what the force applied is. The question tells us the force applied is equal to 200 newtons, right? Bob is pulling the cabinet with a force of 200 newtons, so that's my F applied. All right, so now we need to figure out what the force of static friction is. So we know that the object is refusing to move, so it's not moving. That means it's not accelerating. If it's not moving, it can't be accelerating. So that means that the net force in the x direction has to equal 0. So what are my forces in the x direction? I have F applied, and I have force of static friction, but it's negative because it's moving to the left. It's pointing to the left. All right, so now I can solve for my force of static friction. If I bring force of static friction to the other side, that would make it positive. So force applied equals force of static friction, or I can write it in reverse. Force of static friction equals F applied. So now we know our force of static friction is just 200 newtons. Okay, so what is the force? What is the magnitude of the friction force on the filing cabinet? That's it. The friction force on the filing cabinet is 200 newtons. All right, so we really didn't need to do any of the other work. This is the only important piece of information here. Now, what a lot of people would do with this question is they would say the force of static friction is equal to the coefficient of static friction. times the normal force. And if you were to do that, the coefficient of static friction is 0.80, and the normal force, as it's given in the question over here. Okay, so here's the coefficient of static friction times the normal force, which we had already found to be 294.3 newtons. And when we times those, I'm timesing them on my calculator, I get 235.44. Okay, but if the force of static friction was 235.44, then that would be bigger than the force applied, right? So if I put those numbers in, 235.44, and the force applied we said was only 200 newtons, then what does that imply? It means that the object has a net force pointing in the left direction, which means it's accelerating in the left direction, which doesn't make any sense. I'm trying to pull something this way, and now it's making, like, me trying to pull it this way is not going to cause it to accelerate in the other direction. So the force of static friction can never exceed the other forces, making the object move in the direction of the force of static friction, right? So the force of static friction, the maximum value that it could be here is 200 newtons, right? So that's it. So if the force of static friction was, if this value, when we multiplied these two numbers, was less than 235, let's say we multiplied them and we got 135 newtons, then that means that the net force would be pointing to the right and the object would be moving. But since the question says the filing cabinet refuses to move, we know that the force of static friction must cancel out with the force applied. All right, so this answer over here, force of static friction being 235.44, that would be a common mistake that a lot of people would make. That is not correct. The correct answer is that the force of static friction is 200 newtons. All right, so I'm going to erase this part of the answer, or I'm just going to cross it out so that you can see that is not correct. All right, thanks a lot for watching.